this is Britt Caswell with another example video. In this video, I'm covering example 3 from section 5-4 in the SavvasRealize Algebra 1 textbook. So the focus of this video is to discuss horizontal translations of the absolute value function. And so the problem starts, it says, how does adding a constant to the input, remember that input means the x value, affect the graph of f of x equals the absolute value of x? Now recall the kind of parent equation, or the general form of the absolute value equation looks like this. And so what we are talking about is right here, when we have x minus h, or it might say x plus h, okay? So if you have x minus h, the graph is going to translate to the right. And when you have x plus h, the graph is going to translate to the left. All right? It feels kind of backwards. Now the reason why it feels backwards is because of that minus sign that's in the equation. All right, so that minus sign is what's causing us to reverse the direction of our translation. All right, so now recall that the parent function for absolute value is a v shape with a slope of 1 and -1. It starts at the origin. All right, so this is f of x equals the absolute value of x. So if I start here with, I'll do this one in yellow, the absolute value of x minus 3, that's going to shift us to the right by 3. And again, that comes because of that negative sign in the equation. Now you could do something like create a table of values to tell this, right? Like if I plug in the number 3 here, 3 minus 3 is 0, and so that's where this is. Or a plug in a 4, 4 minus 3 is 1. Okay, you could plug in a table of values if you're ever not sure. But see how the absolute value has shifted now to the right? And so I'm going to go ahead and label this, g of x is the absolute value of x minus 3. So let's talk about the vertex. So the vertex in this case, you could see it. It's right there. It's at 3, 0. All right. Now the axis of symmetry, remember, is that dotted line that goes through the vertex. The axis of symmetry is at x equals 3. Remember, because the axis of symmetry is a line, you have to state an equation of a line. You can't just say the number 3. Okay, it has to be a full equation. And notice that that 3 for my vertex came from flipping the sign and then putting it in the x spot. So in our last video, we created the y value of the vertex from adding something outside of the equation, or outside the absolute value bar. Now we're creating the x value of the equation by adding or subtracting inside the absolute value bar. And don't forget to flip the sign of it when you go to write it in there. Alright, so let's try one more. I'll do this one in red. So this says the absolute value of x plus 5. So what that's going to do is that's going to shift us to the left by 5. And so I'm actually going to end up falling off my graph a little bit, don't I? Right? Because it would come out like that. So my vertex is right there at -5, 0, which you could get, right, by flipping the sign of h and putting it right here. And my axis of symmetry is also going to scoot over because we moved to the left. And so that axis of symmetry is at x equals -5. Alright, so notice that the axis of symmetry is always x equals the x value of our vertex. So there we have it. That is our horizontal translation of the absolute value function. Until next time.